we talked about, insulation is a major thermoregulatory adaptation in mammals and birds. It reduces the flow of heat between an animal and its environment. So it's just referring to the way that an animal keeps the heat within its body. It's like putting a package around it so that it doesn't get released and it can use it for its internal processes. Many land mammals react to cold by raising fur or feathers. This is just another adaptation that helps to keep the heat inside of our body rather than releasing it into the environment. Insulation is important for marine mammals who swim in warmer water colder than their body core. If you think about whales, they have insulating fat that called blubber that lies just beneath their skin and helps to seriously maintain core temperature. So when they're swimming in below, 30-degree water, and even underneath when it gets really, really cold because there's no sunlight, they can still function down there because of insulation, and they're keeping that heat inside of their body and not releasing it into the environment. Yeah, and humans also have this weird thing called brown fat, which is like in our neck, and it's kind of interesting because they found that, what? Okay, because they found that the percentages of the brown fat, which makes up I think 5% of our body weight, is smaller in people who live in colder environments, so that's showing that we actually still use that body fat to keep ourselves warm. I read that in the book. It's a fact. So people who live in California have more brown fat than we do during the winter because we're outside in this cold weather, so we're using that brown fat that's mostly in our neck, so it's not like it's belly fat and stuff, unfortunately. I'm just kidding. And yeah, it's cool stuff. Okay. Just kidding. Okay. Circulatory adaptations. They provide a route for heat flow between interior body systems and the outside world. Many animals alter their blood flow, and then we're talking about vasodilation and vasoconstriction. This is a widening of the superficial blood vessel walls, and the widening of the diameter increases blood flow. So because everybody knows how arteries and veins work, right? One takes blood away from the heart, the other takes them towards the heart.
Which one does which?
Arteries are away, veins are towards, right?
Arteries always away from the heart, no matter what. Veins always toward the heart, no matter what.
No matter what.
No matter what.
Yeah, no matter what.
That's because a pulmonary vein is returning oxygen-rich blood back to the left side of the heart.
Isn't there one artery though that does take it to the heart?
No artery takes blood to the heart.
No matter what. Okay, so vasodilation is widening of blood vessel walls, and if we think about this, because one is going towards and one is going away, if there's more blood flowing through both of those blood vessels, there's more heat being transferred and exchanged, and we all know that we need blood everywhere in our body, so from our head to our toes, there's more heat being exchanged, and it's warming up the inside of our system. The widening of the diameter increases blood flow. Vasodilation warms the skin by increasing the transfer of body heat to the environment, and vasoconstriction has the opposite effect, so it constricts, it like makes them smaller, and then there's less blood flow. Making sense? Right? Correct? Okay. Countercurrent exchange is the transfer of heat between fluids that are flowing in opposite directions, so arteries and veins. Countercurrent exchange. As warm blood moves from the body core and the arteries, it transfers heat to the colder blood, returning from the extremities in the veins. This maximizes the rate of heat exchange because heat is transferred in the entire length of the exchanger, so from our heart all the way to where it's going. And it moves in opposite ways to and from the heart, so it's getting it everywhere, and it's working that way. Cooling by evaporative heat loss. Panting is important in many birds and mammals. For an example, pigeons have a pouch supplied with blood supply in the floor of their mouth, and when they flutter the pouch and pant, evaporation increases sweating or bathing moistens the skin and enhances evaporative cooling. Making sense? Making sense, okay. Behavioral responses. Ectotherms maintain a constant body temperature by engaging in simple behaviors such as hibernation and migration oh no, hibernation and migration are the more extreme version of migration. When cold, ectotherms seek warmer places and expand a portion of their body exposed to heat. So in cold weather, they will find
She's just.
they will find a nice, like, warm place, kind of like if you think about how flowers base their petals towards the sun when it's cold outside. Behavioral responses. Terrestrial invertebrates can adjust internal temperature by the same mechanism of vertebrate ectotherms. So on cold days, the desert locust, Circa gregaria, orients itself in a direction that maximizes absorption of sunlight, kind of like flowers, how they face their petals towards the sun. In cold weather, honeybees increase heat production and huddle together. And they also circulate from the cooler outer edges to the warmer middle. So if anybody's ever seen, I think Planet Earth has something on penguins and how they kind of do the same thing. They'll kind of get in a circle where they're huddling, and then they'll rotate who gets to stand in the warmer middle and who gets to stand in the colder outside. So it's kept even, and nobody dies on the outside. Okay, so this circulates and distributes heat, obviously. In hot weather, they transport water to the hive and fan their wings, which is an example of evaporation and convection. Adjusting metabolic heat production. Endotherms maintain a body temperature much higher than the environment, so they must have mechanisms to counteract the heat loss. It's not 100 degrees in this room, but most of our body temperatures are pretty close to 100 degrees. So we need to have ways to keep our body at that temperature, even when the temperature is like 0 degrees outside. Thermogenesis means to match the changing rate of heat loss. And thermogenesis is increased by muscle activity like shivering. And if you also think about it, when you work out, you feel a little hotter because your body is generating more heat and breaking ATP molecules. Hormones in some mammals can cause mitochondria to increase metabolic activity and produce heat. So our thyroid gland, I think it is, that releases most of our hormones, right?
Well, it releases thyroid hormone,
Yeah.
which is a metabolic regulator.
Yeah, so that when we are in a cold environment, it can cause the hormones to release. And we've all learned about the signal transduction process, how our cells interpret that hormone, and then it increases metabolic activity to produce this heat. And that's all evolutionary adaptation. In some circumstances, reptiles become more endothermic. This is what I was talking about, how an ectotherm can display endothermic qualities. So a Burmese python in a lab experiment shivered to maintain its body temperature. So when they drop the weather like below what the snake is used to being able to function with, it shivered, which is an endothermic property because you're breaking ATP molecules to generate that heat, and it kept its internal body temperature a little warmer.
And females who lay eggs,
Mm-hmm.
they a lot of times will incubate the eggs too. They'll curl around the eggs and they'll actually shiver to just increase the temperature of the eggs.
Yeah.
Sam's got a question.
Yes, Sam.
Yeah, shivering works in people too.
Yeah.
That's why we shiver.
Shivering is the most metabolically demanding activity you can engage in. It burns more calories in a unit of time than even a strict cardio workout.
Wait, really?
Yes.
I sit in a cold freezer.
Yeah, I'm gonna
Shivering-
start
shivering.
Say that again?
Shivering burns more calories. It's a short period of time though, keep in mind. Cardio lasts longer. So overall, the cardio workout is gonna burn more calories, but in a unit of time, shivering burns more calories than anything else you could do.
We talked about the brown fat in the neck that is specialized for rapid production. Yeah. Oh, and when we raise our hairs, that's also to keep the heat. Well, we didn't used to be like, I don't have a lot of hair on my arm or my face, but like back when we were less civilized animals.
Our ancestors.
When our ancestors had more hair, it was a little more effective to raise, get goosebumps is what I call
Right,
it.
and it creates dead air space between the hairs.
Yeah, between the hairs, and it kind of keeps that heat in between your skin and your body hair. Okay. And we have lost our hair over time, but we still use that process, even though it doesn't really have a lot of
Right,
effects.
so we just get goosebumps. The body doesn't know any better.
Yeah, the body doesn't know any better. Acclimatization in ectotherms includes adjustments at the cellular level. And this slide was put in backwards. Acclimatization means to accustom or become accustomed to a new climate or environment or adapt. So in ectotherms, it includes adjustments at the cellular level, and acclimatization to the seasonal temperature changes often include adjusting insulation. Most animals get a thick coat in the winter and then shed that off in the summer. Physiological, thermostats, and fever. A complex system based on feedback mechanisms helps regulate some animals' body temperature. We talked about this a little bit, how we release hormones when we're colder and when we're hotter to help keep those processes in tune with how they are demanded by the environment. I mean, what demands the environment puts on us. Okay. The hypothalamus is a region in the brain between the thalamus and the midbrain that function as the main control center for our autonomic nervous system by regulating sleep cycles, body temperature, appetite, etc. And that acts as an endocrine gland by producing hormones, including the releasing factors that control the hormonal secretions of the pituitary gland. So that's a lot of facts, but the important part to get out of this is that we regulate our body systems using hormones. I have like 2 more slides.
All right, I'm gonna